So, if we expand this, the first thing I want you to be able to recognize when you look at this is if this is expanded, how many terms will there be? How many terms will there be? There will be 5 of them. The number of terms when you expand is always one more than the exponent. And if you think of squaring something like a plus b squared, you'll have 3 terms, a trinomial. So that's sort of a hint to figure out how many there will be. Now, if you go to Pascal's triangle and you find out when will you have 5 terms, that happens in this row where you have 1, 4, 6, 4, 1. So if we went to expand this, we're going to have the following coefficients, 1, 4, 6, 4, 1. And each time we're going through, it's going to start off with having 3b to the power 4, and then we'll have 3b cubed, and then 3b squared, and then 3b to the 1, which you could just write like that. And that's how that first term in the expansion will occur. What will happen with the minus 1? Will there be any minus 1s in the first one? No. But there will be 1 minus 1 in the second one, 2 minus 1s, then 3 minus 1s, and finally 4 minus 1s. So whatever the first term in your binomial is, that one is going to start by having 4, then 3, then 2, then 1. Whatever is the second term, the negative 1, will start with 0, and then 1, then 2, then 3, then 4. What happens to this 3b when it gets to the power 4? The 3 is to the power 4, and the b is to the power 4. So this will turn out to be 81b to the 4 plus. What happens when that 3b gets cubed? You're going to get 27b cubed times by a negative 1 times by a 4 will come out to negative 108b cubed. You see what I'm doing all the way? I'm doing my order of operations. So here I would square first, give me 9. 9 times 6 is 54. Negative 1 squared is positive 1, so this one will be plus 54b squared. And you could figure out the rest of them and get minus 12b and plus 1. To simplify it completely. So sometimes you're going to be asked to expand something completely, then noticing those patterns that we saw the other day where the coefficients start from Pascal's triangle, and then the first term starts with the highest power and goes down by 1. The other one starts at 0 and goes up by 1. And then you can simplify it from there. So the questions you can do for this one are 3 and 4. Now on the next page, we'll just go and look at that for a second. You have the following expansion. And we're also going to look at, and right at the bottom of the page, exactly, oh, it's on the next page actually, what the formula is for this expansion. But what they want you to see is that the numbers in front, NC1, NC2, NC3, NC0, all of these numbers in front are combinations. And we've learned that those combinations also appear in Pascal's triangle. 4 choose 0, 4 choose 4, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4 would be the next row. So in our lab that we did the other day, we recognized that Pascal's triangle, the numbers in front, come from combinations. So that's why they've written these combination things in front. Then whatever your first term is, that one, well, I've underlined it in green. Here, I'll underline it. Whatever this first one is, that one starts at an x to the n. Then it goes x to the n minus 1, then n minus 2, then n minus 3. And it keeps going down by 1 until you get 1, and then there's none left in the last one. So whatever that first term is, you start with that one to the power of n, whatever your exponent is, and go down by 1 until you have none left. And whatever is your second term in your binomial, in this case it's a y, it starts with none of them, then you have 1 here, then you have 2, then you have 3, and it keeps going all the way till the end where you have all n of them. There's always n plus 1 terms. Because if you think about starting with 0 and going all the way up to n, that would count n plus 1. Now, on the next page, we'll just look at this right away. You have this formula, the general term, the kth term. And on your formula sheet, just so that we have the exact same one that we can write down that you'll get on your formula sheet and what it looks like. On your formula sheet, they look at actually the k plus 1th term. Term k plus 1 is equal to, well, the beginning always has n choose something. So if we were looking at, and let's go back to here, okay? If I was looking for the third term, 1, 2, 3, can you see that the coefficient in front is n choose 2? If we were looking at the fourth term, 1, 2, 3, 4, then you have n choose 3. If I was looking at this row and I wanted to find the fifth term, I would go 1, 2, 3, 4, 5. I would have n choose 4. What do we notice about what we're choosing compared to the term position? It's always 1 less. So one of the reasons on your formula sheet that they use term k plus 1 is because what's 1 less than k plus 1? 1 less than k plus 1 is just k. So the number in front is always n choose k, which is 1 less than whatever the term that you're finding. On the formula sheet, they use, instead of x plus y to the n, they use a plus b to the n, and use a as the first one and b as the second one. But it should work out to the same idea as if it was x plus y to the n. And your first term is a. What is the exponent? If you were finding the third term, what exponent would be here for a? It'd be n minus 2. Okay? If you were finding the first term, it would just be n. If you were finding the second term, it would be n minus 1. The third term has n minus 2. The fourth one has n minus 3. So it's always n minus 1 less than the term that you're trying to find. What's 1 less than the term that we're trying to find? K. So this will be n minus k. Does that make sense? If you were finding term 5, then k here would be 4, because 4 plus 1 would be term 5. And for term 5, if we go back to this again, well, I'll use term 4 because so term 1, we have x to the n. Term 2, we have x to the n minus 1. Term 3, we have x to the n minus 2. And term 4, we have x to the n minus 3. So whichever term you're finding, that first exponent is always n minus 1 less than the term. So if we're using term k plus 1, 1 less than k plus 1 is k. What's the exponent of the second one? Look again for a pattern. Look at the previous one. Now we're looking at the y, the ones that are circled in blue. The first one, there are no y's, so what's the exponent? 0. The second one, there's 1 y, so what's the exponent? For the third one, there's 2 y's. 2. So we notice a pattern for almost everything. Whatever the exponent or the things that we're looking at is always 1 less than the term number. And in our formula, 1 less than the term number is always k. So for this one, it will be b to the k. So some things just to help you. What is k? It's your k is always 1 less than the term number. What does the n stand for? No, not quite the number of terms. N is the exponent. It's right here. So whatever your exponent is in what you're trying to expand, that's your n. What's your a? Your a is your first term in the binomial, and b is the second term. In the binomial. And the big C is for n choose k.